While we are highly trained professionals dealing in complex mathematical procedure, we do encourage you to try this at home as it will hopefully enhance your understanding of circle theorem. So welcome back to 1 Less Than 3 Math. This is a really special video because I've just hit 100 subscribers. Thank you so much to everybody. We've got the limited edition hamster face thumbnail to celebrate. And this is the third video in the 10 minutes, 10 marks playlist. It's a special edition on circle theorem because it is everybody's favourite, and that is said with a lot of sarcasm, hence the yuck face next to it. However, I want to change that, and I want you to be enjoying circle theorems by the end of this video, or at least understanding how to do some of them. So, if you'd like to have a go at the questions, please pause the video now before I proceed with the solutions and explanations. So we're going to look at this first question, the top left question, where we need to find x and y. Now, when you've got a diameter that forms a triangle with two chords, the angle where the two chords meet at the circumference is always a right angle. Consequently, we can work out angle x because the angles in a triangle add up to 180 degrees. So we can add those two angles up. 42 add 90 is 132, and we can subtract that from 180 degrees, giving us 48. So we can write x equals 48 degrees. Now the next part is to find y. Now when you have a radius that meets a tangent, the angle is always 90 degrees. So we have another 90 degrees angle here. Now, because we know x is 48 degrees, it's a simple case to find y. We know that x add y equals 90 degrees. So y is going to equal 90 take away 48, because we know the x is 48. 90 take away 48 is 42 degrees, so that's the value of y. So that's the two solutions for x and y. We'll move on to the top right question now, where we need to again find x and y. Now, we've got a pair of angles that pair up to find x. X is going to equal 75 degrees. Now, the reason for this is because the angle between a tangent and a chord is equal to the angle in the alternate segment. So basically you've got the angle of 75 that is the angle between the tangent and the chord, and that's equal to the angle in the alternate segment. So basically you've got this situation where we've got x equals 75 degrees. I'm just jumping ahead there, I'm going to jump back a second. So x equals 75 degrees, we can't see the 7, it's hiding behind the angle, but trust me, x equals 75 degrees. Now, we now need to find y. Now, when you've got a cyclic quadrilateral, that's a quadrilateral within a circle where each point of the quadrilateral touches the circumference. So here's our cyclic quadrilateral. Now, the opposite angles in the cyclic quadrilateral add up to 180 degrees. Now we've got a triangle as well, so we can find the angle at point D. And the angle at point D and angle Y are going to add up to 180 degrees. So I've moved the 75 into full sight now, and we can work out the angle at point D by doing 35 add 75 is 110 degrees. Subtract that from 180 degrees. So we have the angle at point D. We could call that angle CDA. That's 70 degrees. Therefore, the angle at Y, well, we now know that Y add 70 is 180 degrees. So Y is going to be 180, take away 70, which is 110 degrees. Because as I say, the angles that are opposite each other in a cyclic quadrilateral add up to 180 degrees. So now, bottom left question, we need to find P and Q. Now we're looking at segments here, and quite simply, the angles in the same segment are equal. So P is going to equal 44 degrees. We can see the two segments there. and they are going to be full of the same angles, so P is going to be 44 degrees because angles in the same segment are equal. Now, we then need to find Q, and we're going to go back to our cyclic quadrilateral. So there we can see the angles that are the same. Obviously, you'd have a pair of opposite angles in the middle, and the angles in the other part of those triangles would also be equal. So now we identify our cyclic quadrilateral. Now, the 85-degree angle is going to be the same as the angle BCD, the whole angle. Now that's 44 plus Q. So we can set it up like this. Q plus 44 plus 85 equals 180. So we've got basically one angle is Q plus 44, the other angle is 85, and they will, because they're in a cyclic quadrilateral, add up to 180 degrees. So simplifying that, Q plus 129 equals 180, Q equals 180, take away 129, so Q equals 51 degrees. Finally, in the bottom right, we need to find X and Y. So let's go ahead and do this. Again, we've got angles in the same segment that are equal. The X angle and the 40-degree angle are going to be equal. So we can see that these two angles are going to be the same because they're in the same segment. X equals 40 degrees. Now that allows us to find some other angles. We've got an opposite angle here, so the angle APE is going to be 75 degrees. That allows us to find the angle AEP. It's always the letter in the middle. So we do 40 add 75, it's a triangle. So 40 add 75 is 115 degrees. Then 180, take away 115 degrees is 65 degrees. So the angle here is 65 degrees. Now we're going to go back to our cyclic quadrilaterals again. Identify your cyclic quadrilateral as we have done here. And the opposite angles are going to add up to 180 degrees. So this one and this one, the Y and the 65, add up to 180. So obviously we solve that to find the value of Y. Y equals 180, take away 65, which is 115 degrees. So there we found both angles. So, as you may notice in the top right hand corner, we now have the heart eyes emoji because I hope that you now have a bit more understanding of circle theorems. There'll be more videos coming on it, more explanations. It's quite a difficult topic, so please refer to BBC Bite Size or Corbett Maths or whatever if you want to gain some more understanding, and I'll be making some more videos too. So I hope this has been helpful. Hasta la pizza, arrivederci, so long, goodbye, au revoir, we'll see you next time, ciao for now. Thank you everybody, and thank you for the 100 subscribers. We're moving up, 1 lesson 3 math.